Good morning. Hey, it's 6-1, part 2 today. Still working with exponents though. So let's continue on. We'll pick up some more rules. Yesterday we worked with um, product of powers and products of quotients. Well, today we're seeing the power of a product. So just a little bit different. Let me see. I think get some ink going here. There we go. And make that a little skinnier so it doesn't take up the whole page. All right. Whoops, that didn't save. I will be all together here in a moment, guys. All right, we are ready to roll. So, just looking at this rule here, it says if I have two bases raised to a power, I basically can distribute that power to each of them. And that's what we're seeing here, a to the m, b to the m. And here's an example, 3 times 2, all raised to the fifth power. That becomes 3 to the fifth, 2 to the fifth. So pretty intuitive that just distribute the power. Quotient, same idea. Distribute the power to the numerator, the denominator. It'll end up looking like a to the m, b to the m, and you can see a concrete example there. So let's just roll into example 4 and do it. So I do see two things multiplied. Do you? Negative 1.5 times y. So I can distribute this squaring to each of them. That would give me a negative 1.5 squared times a y squared. Now, when I square a negative, of course I'm going to generate a positive, aren't I? And 1.5. This might be where you want to use your calculator. Otherwise, 15 squared, I believe, is 225, and we could move our decimal places off of that. But let's go, whoops, that's not what I wanted. I wanted the negative. 1.5, close that parentheses. If I put that negative in parentheses, this will cause it to get squared. Now on the graphing calculator, we have a dedicated squaring key, and probably on most scientific calculators, there's the dedicated square key. So I'm going to use that one. Yep, there we get 2.25, and of course it's positive. And then y squared is easy. You will find that you like variables more than you like numbers when you're doing exponents, because the variables are really pretty easy, aren't they? I'm going to distribute to both of those. Why don't, for your notes, you draw it in on both of them. Show that distributing. So I get an a cubed over, now negative 10 quantity cubed means negative 10 times negative 10 times negative 10, which of course is going to be negative, negative makes positive. But then I've got this 100 times a negative 10, and that's going to switch us back so that we're negative again. So I'm going to have negative 100 times 10 brings on one more zero. So we're going to have a cubed over a negative 1,000. Now, how often do you see the negative in the denominator? We did here, but it does look kind of strange, doesn't it? I would put the negative either in the numerator, or the other option that we commonly see is just out front of the fraction. So you take your choice there. All right, let's distribute, distribute, distribute. I'm going to get 3 to the fourth, d to the fourth, 2 to the fourth, and then we can simplify. 3 to the fourth is 81. I have it memorized. You will too after a bit, because we will be using these over and over. 2 to the fourth is 2 times 2 is 4, times 2 is 8, times 2 again is 16. So 2 to the fourth is 16. When we finally get back to class, I do have a powers table to give you where we can just look it up on a sheet of paper, which might be faster than throwing it in our calculator at times. Okay, D, a little extra challenge. The extra challenge is the fact that we've got this negative, right? So we know from yesterday what negatives will do, but let's distribute. So this is going to go to each and every item, and I'm going to end up with 2 to the negative fifth, x to the negative fifth, and 3 to the negative fifth. Well, negative exponents cause things to go from top to bottom or bottom to top. So my 2 to the fifth is going to sink down below. I will write it as a positive now since I moved it. X to the negative fifth drops down below. What happens to 3 to the negative fifth? You're right, it moves to the top. That negative bottom will move it to the top. Now, 3 to the fifth, ooh, that's a big one. That might be calculator time for me. 3 to the fifth, I think it's 243, but let's just double check. Yep, 243. 2 to the 5th, I know that one, it's 32 x to the 5th. All right, E, distribute, distribute, and that's going to look like negative 3 cubed. Is that going to turn out negative? Yes, it will, because of an odd number of power with a negative sign will make us stay negative. Now I get x to the 4th raised to the 3rd. This is power to power property now, isn't it? And what do we do with power to power? Yesterday we learned that we multiply it. So that's going to give us an x to the 10th. I went ahead and did 3 cubed. Hopefully you know 3 cubed is 27. So there we go. Otherwise, use your calculator. Another negative power? Okay. So I'm going to end up, I'm going to write down here, negative 3 to the negative 2, c to the negative 2, over 4 to the negative 2. Well, we know every item is going to switch positions. If it were numerator, it's going to become denominator and so forth. Those negative exponents change things up, don't they? So I'm going to have negative 3 to the positive 2. C to the negative 2 drops to the bottom as a C positive 2. And then 4 squared moves to the top. And let's finalize by expanding our numbers. 16. Negative 3 times negative 3, of course, is going to be positive. Positive 9, C squared. So hopefully that went okay for you. If I went too fast, go back and review or slow down the video. Let's move to the next page. We pick up, oh, we're still on these rules. But as you can see, number 47 and 49 are major. Like there's a lot going on there. So these are very similar. I think you have maybe like 48 and 50 to do in homework. That's why I wanted to include these so that you have an idea of how to do these fancy ones. Okay, well, it's a distributive step, isn't it? So I'm just going to distribute to each and every item, including bottom, and that's going to be a lot to draw arrows. So let's just go for it. 2 to the 4th. X to the negative 2 raised to the 4th, y to the 3rd raised to the 4th. Now I realize some of you could do that work right now and put it down correctly. Go ahead if you know that power to power is going to be multiplying. I'm just showing, pretty much every step that you could possibly think of. So it does slow me down and makes me show a little bit more work. And I know many of you probably are like, why is she taking it so slow? Mainly just for demonstration purposes. All right, so 2 to the 4th, if you throw that in your calculator, remember from yesterday, go 2, use the caret key, take it to the 4th power, hit enter. Oh, it's 16. So 16 will stay in numerator. This will expand and become x to the negative 8, won't it? Which will drop to the bottom. I'll do it in my next step, so I'm doing this in a few passes. And I get y to the 12th because I'm going to multiply those powers. 3 to the 4th, I know that one. It is 81. X to the 4th is fine. Y to the negative 4 times 4 is negative 16. Okay, my next cleanup step is going to be moving negatives top and bottom. Okay, so 16 stays on top. X to the negative 8th moves down below. That 81 is going to stay, isn't it? So let's just put it down there. Y to the 12th stays top. Got everything accounted for on the top. Now let's deal with x to the 4th. It stays put because it's positive exponent. Y to the negative 16th is going to bounce up above. All right, now using some rules from yesterday, I've got the product of two powers, and for that we add exponents. So we get y to the 28th over 81, x to the, add those exponents, so x to the 12th. And nothing will simplify. I don't see any common factors between 16 and 81, so that'll just stay as well. Okay, it's a lot more work than what we had on the first page, but the properties just get utilized the same as always. All right, I'm going to clear my screen, but I don't have a clear screen button, so let's get one on. All right, now I do. All right, 49. Squared and squared. So we're going to distribute. I'm going to try and do this one a little bit faster, maybe not quite so many steps as we did on the last one. So I'm going to distribute. That's going to give me 9, isn't it? 3 squared. I'm going to distribute. That's going to give me an m to the negative 10th. I'm going to distribute. That's going to give me an n to the 4th. Remember, power to power multiplies the exponents. Okay, down to the bottom, distribute. 4 squared, 16. M, square that, or 2 times the negative 2 will give us negative 4. Ooh, this is a 1, isn't it? N to the 0. And 1 squared is still just 1. Don't really need to write it, but I'm going to just for this one. All right, moving over to the next thing that it gets multiplied by. I'm going to go m squared n. Power to power means multiply. That'll be n to the 8th. Squaring down below, 9 squared is 81, and then n squared. Okay, I have some negative powers. I think I'm going to move my negatives next. And so that's going to give me 9. This m will move to the top. This m will move to the bottom. 16 stays put. N to the 4th stays put. And I don't need to write the 1. In the second grouping, really it just stays, doesn't it? No negative exponents, so I don't have to move them. All right, now what I would like to do is bring together as one fraction. So I'm going to put like things together, because you know how like 7 times 2 times 3 can be written as 7 times 3 times 2. Like we can reorder our multiplication and it does not change our answer. So I'm going to reorganize all of these variables and get like variables together. So I'm going to have m to the 4th, m squared, n 4th, n 8th. There, my top is organized. My bottom, I'm going to have 16 times this 81, then alphabetically list m to the 10th, n to the 2nd. So that was bringing it together as one fraction, right? As one fraction. And organize the order, right? So that it's a little easier to see what needs to come together. Now, with my numbers, 9 will cancel into 81 9 times. So that will be 1 on top. 9 divided by 9 is 1. 81 divided by 9 is 9. So, I got to do 16 times 9. That's too much for me to do in my head this morning. 16 times 9, we're talking 144. Okay, so fraction bar, 144. Aren't these fun, you guys? Let's go back up to the top and let's pull together our m's. Yesterday's rules, we will add those exponents. So we get m to the 6th. What will you do with the n's? Yes, power times a power, we will add exponents. So n to the 12th. Okay, when I look down at the bottom, I still have m10, n2. One last step, because we have, let's get a highlighter here. M's over M's, we can simplify that. That's yesterday's rules. We can subtract the exponents. When it's quotient, right, it's subtraction. Let me get back to my pen. So I still have my 144. 6 minus 10 is negative 4. I'm going to have an m to the 4th on the bottom. N to the 12th over n to the 2nd. 12 minus 2 is a positive 10. I'll stay on top. Okay, so this ended up being n 12 minus 2 equals n to the 10th. That made it a top value. Whereas the m's, let me just tell you what we did on that again. We took m to the 6 minus 10, which gave us m to the negative 4. That tells me it belongs in the bottom. And as you can see, there were more m's. We add to the 10th power. More m's in the bottom. They're going to remain then in the bottom. Sorry about that. I had to blow my nose. All right. Those are difficult. Those are tough. All right. On to scientific notation. We could put scientific notation in our calculators, but I'm going to show you how to do it by hand, okay, using the rules. So another thing to highlight is if we have it, we want a form a times 10 to the some power. A has to be a number between 1 and 10. That means it's single digit. There has to be only, whoopsie, there only can be one digit to the left. Let's say I get 595. Only one digit to the left of that decimal point. So that means it's a number that fits between 1 and 10. Is that true? Yes, 5.95 is between 10. What if I had written 59.5? Does that fit between 1 and 10? No. So I will have to do that adjustment. Hopefully you kind of remember some of your scientific rules, notation rules. All right. Like before, we can reorganize. So I'm going to take, because really this means multiplication, doesn't it? All of this is multiplied. So I'm going to reorganize. So change the order of my items. And that means I'm going to take 3, multiply it by 1.5, and then I'm going to move my tens together. 10 to the second will multiply by 10 to the negative 5. Now, you'll notice I kind of gave myself a special multiplication symbol there just to follow suit with what I expect to see in scientific notation. All right, 3 times 1.5. Throw that on your calculator if you want, or maybe most of you know it, that it's going to be 4.5 times, now, powers that have bases the same means we can add our powers, and we get 4.5 times 10 to the negative 3. Beautiful. That's our final answer because A fits between 1 and 10, right? 1, 4.5, less than 10. Our A value is perfect. And by A value, I'm referring to what they were up here, right? That we have some A times the power of 10. All right, there's that one. Next one, division. I'm going to reorganize. So I'm going to think of this as 6.4 over 1.6 times, there's my fancy time sign, so it sets up for scientific notation. Now, calculator, let's use our calculator. 6.4 divided by 1.6 gets me 4 times 10 to the 7 minus 5, right? With a quotient, you subtract the powers. So I get 4 times 10 to the second. And that number 4 is fine because it's a number between 1 and 10. So my A value is perfectly set up for scientific notation. All right, we have a couple real life situations here. Let's run through them. A jellyfish, ooh, never been bitten by one, thank goodness. A jellyfish emits 1.25 times 10 to the 8th particles of light, or photons, in this amount of seconds. Really, really small. Really, really fast, I guess. How many photons does the jellyfish emit each second? So this tells me right here how to set up my problem, doesn't it? I want photons per second. Photons each second. I could think of this as per, couldn't I? Photons. So I need the photons on top. There's the photons. And then here's the seconds. And just by understanding what it was asking for, it sets the problem up for me. So then I wrote that out. Now I reorganized. But hey, be careful. I believe on your copy, it might say 9 on the written copy because I have a typo. It is an 8, just like it was there. All right, let's go grab our calculator. Let's do 1.25 divided by 6.25, and we get 0.2 times 10 to the 8th minus -4, because we'll subtract exponents, right? Now that gives me 0.2 times 10 to the 12th. Now, is this a number that fits between 1 and 10? No. So we have to make an adjustment. This needs to slide over, doesn't it, to create the number 2, which does fit between. Now, this was going to move to the right anyway, wasn't it? We're making a larger number. I helped it by moving to the right by 1. Moved by 1 to the right. So I have to lessen this by 1 because I already shifted one unit, okay? That's the only thing tricky about scientific notation is when this A number is not between 1 and 10, you have to do your adjusting. So we had to do an adjustment. Make a note to yourself so you remember to always check that that number fits between 1 and 10. All right, I think we're on to the very last problem. This one has the solar system involved. It takes the sun about 2.3 times 10 to the 8th years to orbit the sun of the Milky Way. It takes Pluto about 2.5 times 10 to the 2nd years to orbit the sun. All right, so the sun going around the Milky Way and Pluto going around the sun. How many times does Pluto orbit the sun while the sun completes one orbit around the Milky Way? Oh my goodness, that's a lot, isn't it? So here's what I thought. Let's talk about the time for the sun to orbit the Milky Way. Then, how many times will Pluto have to orbit the sun in that amount of time? Here's the typo. Okay, it was on this one. So make sure you got 10 to the 8th there. It wasn't on the last problem. So I grabbed the numbers about the sun and Pluto, and there we go. And years will cancel years on here. So we're going to be left with just the amount of a number, really, an amount of time, won't we? It's not erasing. All right. Calculator. Let's take 2.3. Oh, here I reorganized, didn't I? Reorganized my number. And got the tens grouped together, got the numbers grouped together. So 2.3 divided by 2.5 turns out to be 0.92 times, subtract our exponents on the tens because it's a quotient, and that's going to end up being 0.92 times 10 to the 6th. Now, 9 is 1 smaller than 0.92? No. So we need to do an adjustment. Let's slide our decimal point. This will become 9.2 now. If I adjust it, I need to then reduce or adjust this. Since I already slid 1 to the right, I'm going to reduce this down by 1 and drop it to a 10 to the 5th. So this would be the number of times Pluto circles the sun while the sun circles the Milky Way. You know, let's write this out in standard form. So it's 9, 2. There's 1. Now we got to move it 5 times. So there was 1, 2, 3, 4, 5. My decimal point will end up right there. That will require 4 zeros, won't it? So I move to the right because this is a large number. And now let's throw in our zeros and there's standard form. Perfect. All right, homework is located in Schoology. You can see some of the scientific notation problems and so forth. And then there's a few of these fun ones too. If you get stuck on this last page, look at the answer key that I posted and see if you can figure out what I was doing there. All right. Have a great day, you guys. Bye bye.